Hi, and welcome to Lesson 3.08. We're going to learn about ionic bonding and writing formulas, which includes covalent bonding and acids. These are some of the standards that we are addressing with this lesson. These are located in the course. Click on Course Information, then Standards to read them. The lesson objectives. After completing this lesson, you will be able to apply the rules of nomenclature, which is a big fancy word for naming, to name a compound when given its formula. Also, we will write formulas for ionic and covalent compounds from their names. Please make sure that you have 100% completely mastered 3.05. If you have not, 308 will be that much more difficult. From 305, we have our common charges periodic table. If you do not have this already in your notebook, which you should, but if you don't, please go back to lesson 305, get this periodic table, print it, and put it in your notebook. You need it for easy reference. It tells us what the charge of each of the main group elements are. 308 contains a lot of information. Please be patient with yourself. It is not a lesson that you can do in an hour and understand it. By the end of 3.08, you will be able to name and write the formula for millions of compounds. It's kind of like learning a new language. So it does take time. The more practice you get, the better and easier it will get. Please do not expect that you will watch this recording and be able to name everything. We are going to start with ionic naming. And remember, ionic naming is where we have a metal plus a non-metal. That's what the M and NM stand for. There are three types of ionic compounds we're going to look at today. We're going to look at binary ionic compounds, which you learned how to write the formula in lesson 305. We're going to learn how to name those compounds, and we still need to be able to write the formulas. We're going to learn how to do ionic compounds with polyatomic ions, and we're going to include those special metals. The middle of the periodic table, those transition metals, and lead and tin. We're going to learn how to name them because they have something special in their name. After we do these three, we're going to do a quick comprehension check, and then we're going to go on to covalent naming. Covalent compounds are where you have a non-metal bonded to a non-metal. Therefore, there's no ions. So you got to get your mindset different. You can't keep the ions in your mind because that'll mess you up for covalent. Finally, we're going to get two different types of acids. We see our binary acids and then our oxyacids. There are three types of ionic compounds. Anytime we say main group element, this is what we're referring to. Group 1, group 2, and then groups 3 through 8. Our special metals are what we refer to these transition metals in the middle of the periodic table, lead and tin. So later, when I say, is this a special metal, this is how you're going to know what I'm referring to. Ionic compounds number 1, let's go through our binary naming. Binary means that you have only two different elements, a cation and an anion. Only two elements. So when you look at your formula, you see only two different elements. NaCl, two elements. That's it. Now, if you have a main group metal, okay, so if you have an ionic compound, metal, non-metal, we have two elements, that's binary. If this is a main group metal, all we do is name it. Get yourself a periodic table that has the names in there if you don't know the names already. We do have a periodic table in the course under course information. So we look at the periodic table and we see that Na is just sodium. So we're going to name it sodium. Then we're going to name the second element. We're going to write out the name, but we're going to focus on that root word. And for chlorine, the root word is going to be chlor. Then we are going to change the ending to IDE. So we're going to cross off the ending, we're going to add IDE. So the name of this compound is sodium chloride. Let's get some practice naming those anions. Anion is always the second element. So the second element always drops the ending and has the IDE ending. So we're going to change this to IDE. So what I want you to do is to write the ion name. And when you're ready to resume, hit play and we're going to show the answers. Welcome back, and here we go. I hope you did well. Nitrogen becomes nitride. You have to be careful because sometimes students want to keep nitroj and turn it nitrogide. No, 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 that's not right. Nitride, phosphide, oxide, sulfide, selenide, fluoride, chloride, bromide, iodide. And some of these may sound familiar to you just in regular life. You know, you have fluoride in your water for your tea. Sodium chloride is table salt that you shake on your French fries. Now I know we've only gone through one problem, but most of this is old stuff. The rule is not difficult at all. I would like for you to pause this recording and try these on a sheet of paper at home. For 1, 2, and 3, name the compounds. 4 through 6, I've given you the name. I want you to write the formula. And big hint here, you have to have that common charge periodic table from lesson 3.05. You have to have that table so you can figure out the charges for these elements to be able to write that final formula. So hit pause, and when you're ready to resume, hit play. Number 1, magnesium is a main group element, therefore I just name it. And then I take the second element and I write out the name, but I'm going to change the ending to IDE. So it's going to be magnesium chloride. Number 2, aluminum is a main group element, therefore I'm just going to name it. And then I name the anion, changing the N to IDE, so it's nitride. Number 3, ionic compound, metal, nonmetal. Potassium, K, is a main group element. Bromine, Br, is bromine, but when we're naming ionic compounds, we change the anion to IDE. Now again, we're talking about monoatomic anions, right? It's just chlorine, just nitrogen, just bromine. That's the key. Number 4, it says calcium oxide. Okay, so I know what calcium is Ca. Oxide is the ion for oxygen. Now I look up on that periodic table from lesson 3.05. Calcium has a common charge of 2+. Oxygen has a charge of 2-. In the recording for 305, I went through 2 different ways to write your formulas. You can crisscross and reduce, or you can do it the long way, which is really not the long way sometimes. We look at calcium, we have a 2+, oxygen has a 2-. We need only one of each, right? Because 2+, 2- equals 0. When we look at the charges cancel. Therefore, my formula is CaO. Number 5, lithium is Li. Sulfide is the element sulfur. Okay, IDE ending tells me it's the element on the periodic table. Lithium is a main group element. I look on that periodic table from 305. It tells me lithium has a +1. Sulfur is in group 6, therefore it has a 2-. Now I can crisscross and reduce, just the number comes down. Lithium has a charge of 1+, I don't have to cross the 1. So my final formula is Li2S. Number 6, barium is Ba. Phosphide, remember, is the element. The IDE ending tells me it's just the element. Phosphorus, barium has a charge of 2+, phosphorus has a charge of 3-. We can crisscross and reduce only the numbers, and we get Ba3P2 as my formula. If you struggled writing the formulas, you need to go back to 305. 305 was all about common charges for main group elements and writing those formulas. The second type of ionic compounds that we're going to learn about is when we have polyatomic ions. Polyatomic ions are very confusing to students in the beginning. Much like with everything, you just got to practice. The more you expose yourself to it, the more practice you do, the better you're going to get. Now with practice, that means that you are actually doing these at home. You're not just watching me when I tell you to pause the recording, that you're just letting it go and then you're writing down the answers. You'll never learn it. You have to do the work, and it will take time, so be patient with yourself. This is definitely a lesson that takes a while to get. Alright, polyatomic ions are basically a group of atoms that are themselves covalently bonded together, and they act kind of like a family where they have a charge. For example, chlorate, ClO3. ClO3, that's a covalent bond in here. Okay, polyatomic ions are made up of a covalent bond. And these 4 atoms here are bonded together, and all of them together as one unit have a charge of a negative. This will now ionically bond to a metal, but ClO3 is covalent bondedly together. It has a negative charge, which it's going to bond ionically with a metal. You really need to go to lesson 3.08, get this chart printed. Unless you plan on memorizing it all, print it so that way you have it for quick reference. The name is given here. How awesome is that? In 4 columns we have +1, -1, -2, and -3. What's nice about this is that if you have a compound that has this formula, all you do is come here and name it. You don't have to change the ending. You don't have to do anything. Just name it. We have perchlorate, chlorate, cyanide, bicarbonate, sulfate, sulfite, peroxide. I know you guys have heard of hydrogen peroxide. Phosphate. I know you guys have probably heard of phosphates, phosphoric acid. It all comes from this polyatomic ion. So please, these, you have to recognize them. Oftentimes you're going to have a formula that's going to have a whole bunch of elements in it, and you come to this table and figure out which of the polyatomic ions you have. I want you guys to get in the habit of, you look at the formula and you say, okay, is it an ionic or covalent bond? Ionic is going to have metal, non-metal. Look at it and say, how many elements do you have? If you have more than 2 elements, you have a polyatomic ion. So one of these compounds is a polyatomic ion in it. Can you tell which one? If you said the middle one, absolutely. Because this first one is actually binary. It has sodium, chlorine. This third one has aluminum, fluoride. So that's going to be binary as well. Now notice I'm not counting how many atoms, just how many elements. I have sodium, I have chlorine, I have aluminum, I have fluorine. Here I have potassium, I have chlorine, and I have oxygen. If you have 3 or more different elements, doesn't matter how many of each you have, just if you have 3 or more different elements, you have a polyatomic ion. You must look at the table and tell which polyatomic ion you have. The more you work with this, the better you will get, and the less time you will spend answering these questions on assignments, exams, and in future lessons where it is assumed that you know this. Number 2, naming with polyatomic ions. So let's say we present you with the formula NaOH. What you want to do is first determine, is it ionic or is it covalent? Ionic is metal, non-metal. Sodium is metal. Hydroxide, OH, is non-metal. Okay, so I know it's ionic. Now you want to look at it and say, how many elements do I have? Well, I have sodium, I have oxygen, I have hydrogen. So I have 3 or more different elements, therefore I have a polyatomic ion. So I have to use my list of polyatomic ions. When we're naming these, if your metal is a main group metal, just name it. Main group elements, always just name them. Then the anion, if you have a polyatomic ion, find it in the chart, name it. OH is actually the hydroxide ion. The name of this compound is sodium hydroxide. The key is that you go through those series of questions every time you have a new formula. Is it ionic or covalent? Do you have 3 or more elements? Do you have a main group metal? Name the polyatomic ion from the list. That's all you have to do. What I would like for you guys to do is to pause this. Use the last slide as an example if you want to rewind. You need your list of common charges. You need your list of polyatomic ions. And I want you guys to name the first 3 compounds. Number 4 through 6. Do the best that you can writing those formulas. If you have a polyatomic ion, then you need to make sure that it's in parentheses if you need more than 1 to have a 0 overall charge. So go ahead and pause this recording. Hey, welcome back. So the number 1, remember, please get used to following the same pattern. First thing you always want to ask yourself is it ionic or covalent? I see magnesium, which is a metal. Chlorine and oxygen are both nonmetals. Therefore, this is an ionic compound. Then I want to ask myself, do I have 3 or more different elements? Well, I have magnesium, I have chlorine, and I have oxygen. So yes, I have 3 or more, which means I have a polyatomic ion. I have to recognize what the polyatomic ion is. And when I look at this, I see ClO3 is on my list. That's my polyatomic ion. I have Mg. Is Mg a main group metal? And yes, it is. Therefore, we're going to name it. And now for ClO3, you must look up, and we see that ClO3 is actually the chlorate, ATE ending, chlorate ion. So this compound is called magnesium chlorate. Number 2, metal, nonmetals. It's ionic. Do I have more than 3 elements? I have aluminum, I have nitrogen, I have oxygen. Yes, I have 3 or more elements. Therefore, I have a polyatomic ion. I must recognize the polyatomic ion from that list. You look at your metal. Is your metal a main group metal? Yes, it is. It's in the main group part. So this is aluminum. And then I name the polyatomic ion. So I look up NO3 in my list, and I see that this is nitrate. Okay, number 3, is this an ionic bond? Yes, because I have a metal, nonmetal. Do I have 3 or more elements? Yes, I have 3 or more elements. I have a polyatomic ion. So we go to our metal. Is our metal a main group metal? Yes, it is. That is actually potassium. So I just name it. Cn, you must recognize that as a polyatomic ion. Cn is actually cyanide. So this is potassium cyanide. Number 4, calcium is Ca. Again, the more you work with the polyatomic ions, the more you will say, oh, acetate, that's a polyatomic ion. I know what that is. And that's H2C3O2. And now we have to look at our charges. Whatever it says on that list of polyatomic ions, that's the charge. If it helps, go ahead and put the polyatomic ion in parentheses. A lot of students, that helps. It's okay, you can do that. So this is a group. Just pretend it's like X, if you will, and X has a -1 charge. Sometimes that helps. Calcium is a main group element, so I go to the periodic table from 305 and I see that calcium has a +2 charge. And honestly, I'm sure by now you're already learning some of these and you don't even have to look them up anymore, do you? When we're looking at this, we can crisscross and reduce. So Ca, I'm going to put my polyatomic ion in parentheses just because I want to be careful. We crisscross just the number. Acetate has a -1 charge, so there is nothing to transfer over. So that's our formula, CaH2C3O2 with a 2. Some students will ask, do I have to have a parentheses? So let's say we did that, but we needed 2 of them, because we still need 2 of the groups. Well, now I get 22 oxygens. Not good. I need 2 of the acetate groups, so I got to put it in parentheses. Number 5, lithium is just lithium. Sulfite. Now this is where it can start to get a little confusing. Some students get confused. Well, is this just sulfur from the periodic table? Is it a polyatomic ion? I don't know. A quick, easy way. ITE and ATE are always polyatomic ions. So if you see sulfite, you know it is a polyatomic ion that includes sulfur, but it has an ITE ending. So all you have to do is look up on the list of polyatomic ions and you'll see that it's SO3 with a 2- charge. Lithium is a main group element. It has a +1 charge. If we crisscross and reduce, we write Li and we write SO3. I'm going to put my polyatomic ion in parentheses because I'm less likely to make a mistake that way. I'm going to transfer just the number of my charge, 2. Lithium has a +1, so there really is nothing for me to crisscross for that one. So I get Li2SO3. Since I only needed 1 of my polyatomic ions, I don't have to have it in parentheses. Number 6. Well, I know barium is an element. It's on the periodic table, and in fact, it's actually a main group metal. So I'm going to look on that periodic table from lesson 305, and I see it's Ba with a 2+ charge. Sulfate, look at that, ATE ending. Ding, ding, ding. Right away you should say, oh, polyatomic ion. ATE and ITE are polyatomic ions. So I know it's a polyatomic ion that includes sulfur, and when I look it up, I see the name sulfate has a formula of SO4 with a -2 charge. Again, I'm going to go ahead and put my polyatomic ion in parentheses, so that way I'm less likely to make a mistake. So SO4 with a -2, barium with a +2. Wow, plus 2 minus 2, 2 plus 2 negative, that already equals 0, doesn't it? Therefore, I only need one of each ion. Be careful, the SO4 is an ion. I have to keep it together. A lot of students get confused by this because they're like, but I have 4. No, 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 no. You have one of the sulfate groups. And in the sulfate group, yes, you have SO4. But you have only one of those groups. So oftentimes we will write it as BaSO4. Don't let that number confuse you. If you want to go ahead on your paper and keep the sulfate in parentheses, again, there's nothing wrong with it. We don't do that. You won't see it in the course or online or on any exam or anything like that. But you can do it if that helps you, especially if you're just getting started. So far we've learned how to name binary compounds. You name the metal, you name the non-metal, changing the N to IDE. We learned how to name ionic compounds where we have 3 or more elements. With the polyatomic ion, you must have that sheet, the polyatomic ion list, print it, put it in your notebook. We're going to get to our last type of ionic compound naming. Now we get to our special metals. Now we're going to look at the metal, and it's going to be a metal in the middle of the periodic table or lead or tin. Okay. The anion could be a monoatomic anion, like in the binary, or we could see a polyatomic. Naming special metals. As with everything else, what you want to do is the first thing when you see a formula, if you have to name it, you ask yourself, is this an ionic or covalent bond? Ionic is where you have metal and nonmetals. Pb is a metal, therefore this is an ionic bond. Second question you want to ask yourself, do I have 3 or more different elements? Pb is one element, nitrogen is another, oxygen is another. So I have 3 or more different elements, therefore I have a polyatomic ion, which means I need that list. Now to start naming this, we look at the first metal. Is the first metal one of the main group metals? Pb, lead, is over on the right hand side. However, this whole time we've been saying that the transition metals, lead and tin, are what we call special. So although lead is on the right side of the periodic table, he is a special metal. So yes, it is a special metal. In respect to naming, we're going to consider him a special metal, not really a main group metal, okay? So lead and tin are special. What we're going to do when we have a special metal is we are going to just name it. You might be asking yourself, well, that's what we did before. And yes, that is what we did before. However, since lead is a special metal, we're going to add something to his name. It's not just going to be lead. We're going to actually figure out what his charge is, and we're going to put it in Roman numerals after the name. That's not just lead, that is lead 3, and that's how we say it, lead 3. This takes a little bit of time because you have to work backwards. Lead can form multiple different charges. So in your formula, you have to figure out what the charge of lead is. So we know lead is a positive something because lead is a metal and metals form positive charges. I know that I have the polyatomic ion nitrate, which has a negative charge. Now the easiest way to figure out the charge of lead is we have to see how many of each ion did it take to write this formula. I see that I have only one lead. I have 3 nitrate groups. That is what this means. Remember, polyatomic ion in parentheses, this 3 out here tells me that I have 3 of the groups. Each one has a minus charge. So when I add it up, I have a total of minus 3. What does the charge of lead have to be so that one of them equals and balances the negative 3? A positive what? Minus 3 equals 0. Because remember, all ionic compounds form in order to have an overall charge of 0. So if you said a positive 3, you are correct. Because positive 3 minus 3 equals 0. Lead has a charge of positive 3, Nitrate has a charge of -1 because that's what my list of polyatomic ions tells me. Since lead has a charge of +3, that is what I put in Roman numerals. So this is going to be lead 3, and that's how we refer to it. You must have it in Roman numerals, and you must have it in parentheses. You cannot write lead 3. We see this a lot with students. That's how we pronounce it, but we don't write it like that. Okay, so this PB is what we call lead 3 in this compound. Lead is not always a +3. It could be +2, it could be a +4, it just depends on what it's bonded to. So you always, if you have a special metal, you have to look at your formula and figure out what the charge is. Once you do that a bunch, it'll get much easier. You might even get to a point where you can just look at the formula and you know what the charge is. You don't even have to figure it out. You can just tell. Now we're going to name the anion. Well, the anion is NO3, so we're just going to name it. It's a polyatomic ion. So that name is nitrate. NO3 is just the nitrate polyatomic ion. I'm going to give you some examples of why it is important to call this lead 3 nitrate. Consider these formulas. Lead nitrate, lead nitrate, lead nitrate. Very different formula, different compound. They could have different chemical reactivities. Therefore, we have to somehow differentiate. So we're going to call this first one lead 2 nitrate, lead 3 nitrate, and lead 4 nitrate. That is why with the special metals we're going to use a Roman numeral, because there are times where you can have multiple formulas that are very similar, but chemically speaking they're very different. We cannot call all 3 of these lead nitrate, so we must do something, and scientists decided to use the Roman numeral of its charge, of the metal's charge. Wasn't it easy when we had the main group metals? We didn't have to worry about that, did we? Because main group metals always keep the same charges. But with the special metals, lead and tin, they don't always have the same charge. So we must, in our name, identify what the charge is. It's your time to practice. So pause the recording, do the best you can with these 4 problems. Welcome back. Once again, whenever we're presented with a formula, we're going to start at the beginning. Is this an ionic or covalent bond? Well, I see copper and chlorine and oxygen, so metal, nonmetals. This is ionic compound. Then I have to figure out if I have a polyatomic ion. Do you have 3 or more elements? Well, I have copper, I have chlorine, I have oxygen. Therefore, yes, I do have 3 or more elements. Therefore, I have a polyatomic ion. I know to name the polyatomic ion. Okay, I just got to find it in my list. But how about Cu? Is that a main group element? No, it is not. I know that I'm going to name it copper. Okay, remember, it's a special metal, so we still name it. And then I have to put its charge in parentheses. Don't forget about that. You have to figure out what the charge is. And then we have ClO3, which is actually the chlorate polyatomic ion. So we have chlorate. Now we have to figure out what the charge of copper is here. Well, I know that copper is going to have a plus something charge. And then we're going to look on our list of polyatomic ions. Okay, the charge of chlorate is a -1, so we just put a negative. And when we look at our formula, we see that we only have 1 copper and we only have 1 chlorate ion written there. So it only took 1 copper ion to balance the chlorate ion to be 0. So if only took 1 of each ion and chlorate has a -1, copper has to have a +1. So this is copper plus. Therefore, it has a +1 charge. I put 1 in Roman numerals, and there we go. Copper 1 chlorate. Number 2, start at the beginning. Is this an ionic or covalent bond? Well, I have lead, I have metal, nonmetal, therefore this is ionic. Do you have 3 or more different elements? Well, I have lead, I have nitrogen. No, I don't. I don't have 3 or more elements. Therefore, this is the binary. Remember binary, it's just nitrogen. So lead, I have to figure out what lead is. Lead, is it a main group metal? It's actually a special metal, right? Remember, lead and tin, we're considering special metals for naming. So it is a special metal, therefore we're going to call it lead and we have to figure out its charge. We're going to put that in parentheses. Okay, we'll do that in a minute. Okay, so lead something, and then N. Now, since this is a binary compound, remember, N on the periodic table, so it's nitrogen, but remember, we changed the ending to IDE. So it's nitride. It's not NO3, it's not NO2, so it's not nitrate, nitrite, it's just nitride, because it's just the N, binary, on the periodic table, change the ending to IDE. Okay, now let's figure out the charge of lead. I know lead is going to be a positive something. Nitrogen is on the periodic table, forms a -3 charge. And look at this. It took 4 nitrogens to balance lead's charge. So if I have 3 leads and I have 4 nitrogens, what charge does each lead have to be? Well, nitrogen, 3, 6, 9, 12. So nitrogen has a total of 12. And we know that lead has to equal a positive 12, right? Because positive 12, negative 12 equals 0. So if it took 3 leads and they together have a total charge of 12, what is the charge of each lead? 12 divided by 3 is 4. Therefore, the charge of each lead is a positive 4. And our name is lead 4 nitride. Number 3, zinc 4. It's giving us the charge. Therefore, I know zinc is zinc. I know zinc is a metal, therefore it's going to be positive. It tells me what the charge is, so it's 4. I have sulfide. Notice the IDE ending. It has sulf, so I know it's sulfur with the IDE ending, which means it's the sulfur from the periodic table. It's just S. It's not a polyatomic ion. So I look up on the common charges. Sulfur has a charge of -2. So I can crisscross, and I get a positive 4 there. I get a 2 there. Now remember, crisscross and reduce. 2 to 4 can be reduced, right? They can divide both of them by 2. My correct answer is ZnS2. So you got to be careful, because what if I had given you ZnS2 and asked you to name it? The charge of zinc is actually 4, not 2. So be very careful. Okay, copper 2 sulfate, which is a pretty blue compound. I see the Roman numerals, so right away I know I have a special metal. Copper is Cu. The 2, it tells me it's 2 plus because copper is a metal and it's a positive charge, so it's plus 2. ATE ending tells me polyatomic ion. Polyatomic ion, that includes sulfur. So I look up on my list of polyatomic ions. Sulfate, it tells me is SO4, and it has a -2 charge. Well, look at this. 2 plus, 2 minus. That already equals 0, doesn't it? So plus 2 and a -2 already equals 0. I need 1 of each ion. Remember, sulfate is an ion. It's a polyatomic ion. That means they act together. You have to have 1 sulfur, 4 oxygens in the sulfate ion. And I have 1 of them. So to have 1 sulfate ion, this is how it looks. Okay, how are you feeling? I know it's a lot, isn't it? We've learned a lot of different naming so far. Ionic is the hardest, I think. Of course, something being hard is subjective. What's hard to me may not be hard to you. But there's a lot going on here. You know, you have to figure out if you have ionic or covalent. You have to figure out if you have a polyatomic ion or not. And you know that if you have 3 or more different elements. You have to figure out if you have a main group metal or a special metal. If you have a special metal, you have to figure out what the charge is of that special metal. There's a lot going on. And now I think you're starting to see, wow, I really do need to do a lot of practice. If you are super confused, what I recommend you doing is go back and do ionic compounds number 1 and just spend some time on number 1. Then do ionic compounds number 2. Spend some time just on those. And then do ionic compounds number 3 and spend some time on those. And ask your teacher to give you extra practice problems of all ionic compound naming if you want. The only way you're going to get good at this is you're going to have to do lots of problems. The internet is an awesome resource because you can just Google it and get lots of practice online. So use the internet for what it's intended, as a resource to help you learn. Let's do an example. CuSO4. Okay, I know this is ionic because it has copper. Cu is a metal, therefore I have an ionic compound. How many different elements does this have? Well, I have 3. So we're going to go over here. So is the cation a main group metal? No. So we're going to go this. So I'm going to name the metal, include the Roman numeral. So Cu is copper, so I'm going to name it copper. I have to figure out the Roman numeral, and then I'm going to name the polyatomic ion. SO4 is the polyatomic ion sulfate. Once again, I'm going to just use that polyatomic ion list. Now to figure out the charge. Well, I know copper is going to be plus something, because copper is a metal, metals are positive. Sulfate is SO4 and it has a 2 minus charge. I have 1 copper, 1 sulfate in my formula. It's just CuSO4, so 1 copper, 1 sulfate. So if sulfate has a charge of 2 minus, what does the charge of copper have to be? So when I add them together, they equal 0. Plus 2, minus 2. Absolutely. So copper has to be a plus 2. Let's get some more practice, because what do we need? Practice, 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 practice. Let's practice this stuff. Go ahead and pause this recording. When you're ready to resume, hit play. Welcome back. And here are the answers. Number 1, copper 2 sulfate. We've seen that a couple of times today. Number 2, we have a binary ionic compound with a special metal, so it's iron. When we look at the charges, we know iron's going to be plus something. I know sulfur is on the periodic table, has a charge of -2. However, I have 2 of them. So my total charge of sulfur is -4. Iron must have a charge of +4 because it only took 1 to balance the sulfurs. So it's iron 4 sulfide. Number 3, I have a polyatomic ion. I have a main group metal, so it's calcium carbonate. Number 4, vanadium, an element we haven't seen yet, Vanadium is V, Roman numeral 5, oxide. So that tells me that vanadium has a charge of +5. Oxygen's a main group element, so it has a charge of -2. We can crisscross and reduce, and there we go, V2O5. Ammonium is a polyatomic ion, NH4 with a plus charge. Chloride, IDE ending, tells me that it's the chlorine monoatomic ion from the periodic table, so that's Cl with a negative charge. It only takes 1 of each ion to be neutral, so it's NH4Cl. Number 6, tin, 4, so tin has a charge of 4 plus. IDE, so that means the oxygen from the periodic table has a 2. So when we crisscross and reduce, we get 4 there, 2 there, 2 to 4, we can simplify SnO2. So if you did fairly well on that, give yourself a big pat on the back. If you're really struggling, you need to go back and look at each type individually. So please make sure you go back and learn this. Okay, ionic compounds, let's have a comprehension check. Let's go in, all 7, answer them. When you're ready to move on, hit play, and we'll quickly go through them all. Number 1, how many atoms of oxygen are in one formula unit of calcium nitrate? Again, you should be able to name that. So we have polyatomic ion nitrate, so it has 3 on each formula unit. However, I have 2 of them in my formula, so 2 times 3 equals 6 oxygens. What is the name of PbCl2? Use your flow chart. This is a binary compound. It's a special metal. So binary tells me that that is just going to be chloride. I'm going to use IDE ending because I'm binary. Okay, remember binary, 2 elements only. So this is lead, and since it's a special metal, I have to figure out what the charge is. So I know lead is going to be positive something. Chlorine is on the periodic table as -1. I have 2 chlorines in my formula. The charge of lead must equal 2, so that way they balance. Because if the lead is a +2, I have a total of -2, that equals 0. Number 3, I know X is going to be positive something because it's written first. Y has a -1, but I have 3 of them. So if I have 3 of these, that's a total of -3. If I have only 1 of the X's, X has to have a charge of +3. Number 4. Once again, ionic bonding means metal, non-metal. OA. we see P2O5. Phosphorus and oxygen are both nonmetals, therefore that's covalent. B, calcium is a metal, chloride is a nonmetal, therefore this is an ionic bond. C, carbon is nonmetal, oxygen is nonmetal, therefore that's a covalent bond. Number 5, well remember the only time you can have both, remember your covalent bonding is your polyatomic ion. Your polyatomic ions such as NO3, that is a covalent bond in the parentheses. That's covalently bonded. And then it will ionically bond to a metal. So it's an ionic bond. That's how you get an ionic and a covalent all at the same time. So you have to have a formula that has a polyatomic ion. A is the only one. Number 6, ammonium nitrate, magnesium 2-sulfide. The correct answer is B. The reason for that is magnesium is a main group element. It does not need a Roman numeral, and it is incorrect to include it. It's just magnesium sulfide. What is the formula for iron 2 nitride? Well, iron we know is Fe. We know it's positive because it's a metal. It totals the charge. IDE tells us that it's probably the monoatomic ion that includes nitrogen, since it says nitride. So this is the N, which has a -3 charge. So we crisscross, we reduce, and we get Fe3N2. Can't reduce that. And that is it for ionic compounds. Yay! We are done with ionic compounds. We're not done with lesson 3.08 yet though. We now have to go through covalent compounds, which is much easier, much faster, but completely different. So you got to get your mind set different. And then we're going to go through naming acids, which isn't too bad either. So what I recommend that you do is not do covalent bonds right now. Get really good with ionic compounds first. And once you've really tackled that, then go into covalent bonds. Let's do covalent naming. Binary compounds. It does require you to be in a different mindset. We don't have ions. We don't have charges. We don't have to figure out a charge because there is no charge. Covalent bonding shares electrons. They do not transfer electrons. We have a different rule for naming covalent bonds. We are going to write the less electronegative element first. Typically, it's going to be the element that's more left on the periodic table. Remember your electronegativity from lesson 3.03. Electronegativity, you can use the periodic table. Typically, if the element is more left on the periodic table, that's going to be written first. We use prefixes to indicate each element's subscript. So how many elements do you have? How many atoms of each element? We're going to use prefixes. You need to print this. You need this table. How many atoms you have of each element. This is what we're going to use in the name. So this is from the lesson. Go to the lesson, get this table, print it, put it in your notebook. You're going to be using it. Please make sure you write on there covalent naming only. Non-metal, non-metal. Okay, so let's say you have 5 atoms of a particular element. We're going to call it penta. Like pentaoxide if you have 5 oxygens. Or if you have 2 nitrogens, you might have dinitride. Right, let's do an example. Let's say that we have N2O5. So N2O5, we're going to name the first element. That's it. Name the first element, nitrogen. If you have more than one, add the prefix to the beginning of the name. So in this element, I have N2. So that 2 tells me I have 2 nitrogens. So I'm going to call this dinitrogen. Then I'm going to name the second element using the IDE ending. This is the only thing that's the same from ionic. So the second element always has the IDE ending, oxide. And if you have more than or even if you have one, you always have a prefix. Always use prefix for how many there are, even if there's one. Pentaoxide, which oftentimes gets reduced to just pentoxide. Whenever you have the AO, a lot of times it's just pentoxide. So the correct name for this chemical is dinitrogen pentoxide. Let's see you try it. Covalent bonding's not too bad. Covalent name is not too bad. So hit pause, Go back, get that lovely table of prefixes, and name these compounds and write these formulas. Welcome back. Let's get through them real quick. So we have Si is silicon. So this is going to be Si. Silicon. Now I don't have more than one, so I don't need to put mono there. Monosilicon is not correct. We just put silicon. We have oxide, but I have two of them, so I have dioxide. So the correct name is silicon dioxide. Number 2, I only have one of them, so I don't need to put a prefix. Then I have 3 bromines. Bromine, we change it to bromide. I have 3, which is tri. So I'm going to have tri and then bromide, IDE ending. So boron, tribromide. Number 3, notice I have di, then I have nitrogen, I have mono, and then I have oxide. So I have nitrogen, I know I have oxide. Remember, covalent bonds, no charges, just element. Di means 2, mono means 1, therefore N2O. Okay, number 4, we have tetraphosphorus, triselenide. Tetraphosphorus means that I have 4 of them. Triselenide means that I have 3 of them. So P4SE3. That's it. That's all you got to do. There are 2 types of acids that we're going to see. The first one are what we call binary acids. Binary acids, I'm sure you're used to that name now, binary, has only 2 elements. Only 2 elements, same as before. We're an acid, therefore our first element is going to be hydrogen. Always. Hydrogen is always first in acids. That's one quick, clear way for you to say, oh, that's an acid. Hydrogen is going to be bonded to a nonmetal. Hydrogen is always written first. And then we're going to go on to oxyacids. We have 3 or more elements. These are your polyatomic ions. Look at how much more complicated these formulas are compared to binary. Okay, naming oxyacids. So polyatomic ions that ends with the ATE. So what you want to look at is if you have an acid, you have hydrogen written first. You have a polyatomic ion because you have 3 or more elements. Same thing as we did with the ionic bonds. That's how we know. So we're going to name the polyatomic ion. SO4, when you look that up in your chart, it says sulfate. Now to name this as an acid, we're going to change 8 to ic. So it's going to be sulfic. That kind of sounds funny, right? A couple of the acids kind of go back to their original word. So instead of being sulfic acid, they call it sulfuric. And then we're going to add the word acid. So ATE ending, you're going to change it to ic and add the word acid. Sulfuric and the phosphate, those two actually go back to their original word. Sulfuric and phosphoric. Okay, so just kind of keep that in mind. Let's say if we have a polyatomic ion that ends in ITE. So you have this formula, you know that it's an acid because it has hydrogen. SO3 is a polyatomic ion. You look it up on the table and you see, oh, ITE. So if you have a polyatomic ion acid that ends in ITE, you're going to drop the ITE and you're going to add OUS. And then we're going to add the word acid. So if you have a polyatomic ion that ends in ITE, you're going to drop ITE, add OUS. Now, most of the time you're going to keep the root word, but for sulfur and phosphorus, you have to go back to that word. So sulfurous acid. If I said, write the formula for sulfuric acid and for sulfurous acid, this is where you should end up. Notice the difference. IC has one more oxygen than OUS. Okay, so IC and then OUS. All right, let's do some practice. I know this probably will be hard for you, but try to get as far as you can and then name and write the formula. Number 1, I see I have hydrogen, so that tells me I'm an acid. I have 1, 2, 3 different elements, therefore I know I have a polyatomic ion. I know my polyatomic ion is carbonate because that's what it tells me in my list. It's ATE, so I'm going to drop ATE. I'm going to add IC, and then I'm going to add the word acid. So this is actually carbonic acid. Number 2, I know it's hydrogen, so it's an acid. I have 1, 2, 3 different elements, therefore I have a polyatomic ion, which is right here. PO4 is the phosphate polyatomic ion. ATE, I add IC and the word acid. Phosphic, no, phosphate's the other one that kind of does it weird. It's actually phosphoric acid, not phosphic acid. Phosphoric acid. Number 3, acetic acid. The IC, which means it was replaced from ATE, so I know it's the acetate ion. Notice how I'm going backwards. I know it's acetate ion, and I know the acetate ion is C2H3O2 with a -1 charge. It's an acid, therefore I have hydrogen out front. Hydrogen is an ion, H+. So when they're bonding, it's just H2, C2, H3O2. A lot of students will say, but you have these hydrogens separate. Can't you just say C2H4O2? No, you don't want to do that because the polyatomic ion is C2H3O2. You want to keep that polyatomic ion together. So this hydrogen does need to be out front by itself. Hypochlorous, oops, I missed my L there, I'm so sorry. Hypochlorous acid. OUS tells me it's the ITE ending. So my polyatomic ion is hypochlorite ion. So I have to look that up on my list of polyatomic ions. Hypochlorite, that is ClO with a negative charge. It's really, notice there's a hypochlorite and a chlorite. Be careful. So hypochlorite just has one less. So chlorite is ClO2, chlorate is ClO3, hypochlorite is ClO. So that's my ion. I'm going to be an acid, so I know I'm bonding with H+. So it's just HClO because it's -1 +1. Binary acids are pretty easy as well. Let's go through an example as we're explaining how to name it. So let's say we have HF. Binary means you have 2 elements. The first element's going to be hydrogen because that's your acid. So it's going to be hydrogen bonded to another element. So to name, what we're going to do is we're going to use the prefix hydro. So whenever you have a binary acid, it will always start with the word hydro. So if you see the name hydro, all of a sudden you know, oh, binary acid. And then we're going to look at the second element. We're going to use the root name. So we know this is hydrogen and this is the fluoride ion. So we're going to do hydro, fluor. We're not going to write fluoride. We're going to write hydro, fluor. We're always going to have ic at the end, IC. Hydrofluoric. And then we're going to add acid. So hydrofluoric acid. You got to be careful when you're going from name to formula because you're going to see that word IC. Doesn't that kind of remind you of the oxy acid IC? But this is not an oxy acid. This is hydro. So you have to look at that hydrofluoric. That tells you hydrogen fluorine. HF. So be careful when you see the IC, you have to look to see if the word hydro is there. If you see hydro, then you do not have a polyatomic ion. It's just hydrogen and this element. If you have a name that has IC and it does not have hydro, then you know you have a polyatomic ion. Binary acids and writing formulas. Go ahead and hit pause and get to working. Welcome back. I know I have a hydrogen here, so that's an acid. I have only 2 elements, therefore I know it's binary. So I know I'm going to use the word hydro, and then I'm going to name the second element just using the root word. And you know what? Remember with this IC, it's going to be sulfuric. So hydrosulfuric, all one word, acid. Right, number 2, acid. 2 elements, therefore I'm binary, so I'm going to use the word hydro. I'm going to name the root word of my second element, so that's chlor for chlorine. I'm going to add IC and the word acid, so hydrochloric acid. Number 3, hydro tells me I'm binary, so I have 2 elements, hydrogen and something. Nitric tells me I'm nitrogen, so that's HNO. N acid. But be careful, because acids form like ionic compounds. Remember how we said an ionic compound is metal, nonmetal? And remember, way back at the beginning of 3.08, ionic compounds are formed metal or hydrogen and a nonmetal. So we have to be very careful, because hydrogen has a +1 charge, nitrogen has a 3- charge, and so crisscross reduce, it's actually H3N. Notice that over here with H2S for number 1. When you're writing formulas, when you have hydrogen, you have to treat it as an ionic compound, because hydrogen likes to do ionic compounds a lot. Okay, number 4, we have hydrobromic acid. So hydro is hydrogen, so I know I'm going to have hydrogen. Bromic is for bromine, which is Br, has a -1 charge, HBr. 1 and 1. Naming acids flowchart. I have the example on the board. What we want to do is acids we know has hydrogen out front. We want to look at first, how many different elements do we have? Well, I have 1, 2, 3 different elements. Therefore, I have a polyatomic ion, which means I'm an oxyacid. So does the polyatomic ion end in -ite or -ate? So you got to look it up on the periodic table. We have PO3, which is the phosphite polyatomic ion. So that means we got to go over here. So we have the phosphite polyatomic ion. We're going to go down here to the ITE ending. So we're going to name the polyatomic ion, changing ite to OUS. So that's going to be OUS, and don't forget, phosphate and sulfate both change, or phosphite and sulfite, I should say. Remember, we have to actually add more to the name, so it's phosphorus, and then we use the word acid, so phosphorus acid. Let's practice all acid naming. Go ahead and pause this recording. Alright, H2S. I know I'm an acid. I have 2 elements, therefore I'm binary, and remember, for binary we always use hydro, so it's going to be hydro. Then we name the second element, that's sulfur. Remember, we use the whole name for sulfur. We add IC and the word acid, so hydrosulfuric acid. Number 2, we have an acid. We have 3 elements, therefore I have a polyatomic ion, which is going to be our oxyacid naming. And so for this, we look at the polyatomic ion. I know that is the sulfite ion. We change ITE to OUS and add the word acid. Remember, with sulfur, kind of weird, we actually go back to the whole word, sulfurous acid, not sulfus, sulfurous acid. Number 3, I have hydrogen. I have 3 elements, therefore I have a polyatomic ion, which means I'm an oxyacid. My polyatomic ion is SO4. We look it up on that sheet. That tells me it's sulfate. We change 8 to IC, and we use the word acid. So we have sulfuric acid. And I want to draw your attention to the names. If you didn't notice, I had you naming 3 compounds that all had sulfur in it. Now look at all 3 names: hydrosulfuric, sulfurous acid, sulfuric acid. Notice how number 1 and number 3 are very similar, except number 1 has the word hydro, which indicates binary, and number 3 does not have hydro, which indicates oxyacid. Number 4, chloric. I don't have the word hydro, so I know this is going to be oxyacid. So I know I have a polyatomic ion. And the polyatomic ion, it's IC, therefore I know it had the 8 ending. So I know it's the chlorate ion, which is ClO3 with a negative charge. It's an acid, so I know it's bonding with hydrogen plus. So +1, -1, HClO3. Okay, number 5. I don't have the word hydro, therefore I know it's an oxyacid again. which means I have a polyatomic ion. The OUS tells me that it's the ITE ending of this polyatomic ion, so it's chlorite ion. Chlorite ion, I'm going to look it up in the list of ions, and I see that chlorite ion is ClO2 with a -1 charge. It's an acid, therefore it's bonded with hydrogen, +1 -1, HClO2. Okay, number 6. It's supposed to be hypochlorous acid. I'm so sorry, I had an error in here. OUS tells me it's the ITE ending of this polyatomic ion, so that's hypochlorite ion, which is ClO with a minus. It's an acid, therefore it's bonding with hydrogen, so I get HClO. Naming and writing formulas review. So this is everything that we've done. We did 3 types of ionic. We did type 1, 2, and 3. We learned how to name our binary covalent compounds, which are the only ones that exist. We used the prefixes for these. And then acids, we had binary where we use the word hydro. We have oxyacids where we use the ic and ate endings. So thank you so much. It's been great. You are going to use this for Module 3. All of Module 4, you must know 305 and 308, and a lot of Module 5, 6, 7, and 8 for second semester. So I hope you have a great rest of your day, and don't forget about all the other help that the chemistry team has available for you on the course announcement page.